Today we're going to take a hike through the woods. Natural logarithms. See how that is? Natural logs. Okay, so we're going to start with ln of x. And we're trying to remember, what does ln of x mean? Well, remember, the natural log of x, or ln, natural log, really means log base e. That's the only difference. It's just log base e. So, the product, quotient, and power properties all still work for combining and expanding, condensing and expanding logarithms that are natural logs. And I want to remind you of this one as well. I want to remind you that the natural log of e to some power x, what does that equal? Well, what does the natural log mean? Well, we just remembered natural log means log base e. So this really means log base e of e to the x power. So think about the definition of a logarithm. The definition of a logarithm is saying the base to the answer power equals this of number. So e to what power would equal e to the x power? E to what would equal e to the x? Well, right, e to the x would have to equal e to the x. So the natural log of e to the x simplifies just down to the power of x. Now that's going to be important as we start to solve some natural logarithm problems. So the first one I want to take a look at is this one. Let's take a look at the natural log, so ln of 2x plus 4 squared. And let's say that equals 6. So we've got this problem here. And the key thing to remember here is what we want to do is we want to get rid of that natural log. So we need to remember our definition of what natural log really means. It means log base e. So let's rewrite this. Let's rewrite this as log base e of 2x plus 4 squared equals 6. Well, now, if we go back to the definition of a log, like we did up here, the base to the answer power equals the of number. So we can say e to the 6th equals 2x plus 4 squared. Now, we've just got a regular old algebra problem. We can simplify e to the 6th in our calculator. And if we do, we get approximately 403.43. So 403.43. That's an approximation. It's the button on the left-hand side. It's the second function of the ln button, e to the x button. We're going to use the ln button in just a few minutes. So 403.43 equals 2x plus 4 squared. So how are we going to get rid of the square? Yeah, you guessed it. We're going to square root both sides. So we're going to square root 403.43, and that's then going to equal 2x plus 4. But what did we forget? Who put the square root in? You. And that means you need to remember plus and minus. So now when we subtract 4 from both sides, it's not going to go with this. We can get a decimal approximation for that, and it's about 20.085, so let's say 20.09. So we're going to take negative 4 plus and minus 20.09, and that's going to equal 2x. Divide out the 2, and now we can solve our problem for x. So we get x equals, and let's do the subtraction one first. So negative 4 minus 20.09 would be negative 24.09. Divide that number by 2, we get negative 12.045. Now let's do the positive answer, negative 4 plus 20.09 divided by 2, and that gives us positive 8.045. So we end up with two answers for this problem. We come back here and we check where we're at here. We can't have a negative answer in here, so if that negative there gets us a negative, 24 approximately, plus 4, that's going to be negative 20. e to no power will ever give us a negative number, so that's an extraneous solution. This is our only true solution for that problem. Now, let's try a problem kind of slightly in the other direction. Let's try this problem. Let's try 5 times e to the 3x power plus 4.5 equals 15. Now, in this problem, the key thing for us to do is going to be to isolate the e to the power and then natural log both sides. So what do we need to remove? Right, we need to remove that 4.5 by subtracting it. So we start there. And we need to remove the 5. Why did we do 4.5 first? Right, the opposite of the order of operations is what we're following right now. So we did addition subtraction before multiplication division. So we now have 5 times e to the 3x. That equals 10.5. We're going to divide that 5 out now to get rid of it here, giving us e to the 3x equals, gosh, what is that? 2.1. And then our last step, we're almost there. We need to get rid of e so we can bring this power down. And we're going to do that by natural log, what we just learned right here. The natural log of e to the x simply equals x. So the natural log of e to the 3x would simply equal 3x. But why are we allowed to do that? Because we're going to natural log both sides. So 3x is going to equal the natural log of 2.1. And to get x by itself, finally, we're going to divide out the 3. So x equals natural log of 2.1 divided by 3, and we end up with 0.247312448 dot dot dot. Moving on. So we're going to say approximately 0.25. And we could say 247 if we want. But either way, that would be your solution there. There you go, folks. That's the understanding for doing natural logs today. The next video, I'm going to do the alcohol problem for you. So take a look at that one. See you in a few minutes. Bye.